Assalamualaikum warahmatullahi wabarakatuh, and good morning to everyone. I am Harif Badar Baundi, and I'm going to discuss about the structural clay and bricks. So what is clay all about? Clay is a type of fine-grained natural soil material containing clay minerals. Clays develop plasticity when wet due to a molecular film of water surrounding the clay particles, but become hard, brittle, and non-plastic upon drying or firing. Most pure clay minerals are white or light colored, but natural clays show a variety of colors from impurities, such as a reddish or brownish color from small amounts of iron oxide. Clay as the defining ingredient of loam is one of the oldest building materials on Earth. Among other ancient naturally occurring geologic materials such as stone and organic materials like wood. Between one-half and two-thirds of the world's population in both traditional societies as well as developed countries still live or work in buildings made with clay, often baked into brick as an essential part of its load-bearing structure. Also a primary ingredient in many natural building techniques, Clay is used to create adobe, cob, cordwood, and rammed earth structures and building elements such as wattle and daub, clay plaster, clay render case, clay floors, and clay paints and ceramic building material. Clay was used as a mortar in brick chimneys, and stone walls were protected from water. The brick first produced in a sun-dried form at least 6,000 years ago, and the forerunner of a wide range of structural clay products used today, is a small building unit in the form of a rectangular block formed from clay or shale or mixtures and burned, fired in a kiln or oven to produce strength, hardness, and heat resistance. The original concept of an ancient brickmakers was that the unit should not be larger than what one man could easily handle. Today, brick size varies from country to country, and every nation's brickmaking industry produces a range of sizes that may run into the hundreds. The majority of bricks for most construction purposes have these dimensions of approximately 5.5 by 9.5 by 20 centimeters or 2 and 1/4 by 3 and 3/4 by 8 inches. Structural clay products are building brick, paving brick, terracotta, facing tile, roofing tile, and drainage pipe. These objects are made from commonly occurring natural materials which are mixed with water, formed into the desired shape, and fired in a kiln in order to give the clay mixture a permanent bond. Finished structural clay products display such essential properties as load-bearing strength, resistant to wear, resistance to chemical attack, attractive appearance, and ability to take a decorative finish. Brickmaking is one of the most ancient crafts. Well-made bricks have been discovered in ruins at least 5,000 years old. In this country, bricks were burned as early as 1612 in the Jamestown settlement. Numerous brickyards were established in the 17th century. There is some disagreement as to the importance of competition from imported brick in early colonial days. Such brick as was imported apparently was used primarily as ballast for ships carrying an otherwise light cargo. In Ohio, the first bricks were made at Marietta about 1788, where the construction of Fort Campus Martius. Janesville had a plant in 1803, and by 1815 every important settlement in the state had a brickyard. By mid-century, face brick was being manufactured in the state in response to a demand for the product, since the value of both raw material and finished product is low in relation to bulk. Nearness to raw material and market are the determining factors in plant location. Clay suitable for common brick can be found in nearly every part of the country, so that the brickyards manufacturing this article tend to cluster near large industrial and population centers which provide a market. High transportation costs limit the market for common brick to a maximum of 250 to 300 miles for most manufacturers. But the more valuable face brick, which is made of fire clay and in a variety of colors, including light grays, buffs, and tans, that has a wider market. Eastern Ohio and Western Pennsylvania have an especially fine deposit of fire clay that has attracted a large number of producers, whose market extends to the eastern seaboard and as far west as Chicago. Man has used brick for building purpose for thousands of years. Bricks date back to 7,000 before Christ, which makes them one of the oldest known building materials. They were discovered in southern Turkey at the site of an ancient settlement around the city of Jericho. The first bricks made in areas with warm climates were mud bricks dried in the sun for hardening. Ancient Egyptian bricks were made of clay mixed with straw. The evidence of this can be seen today at ruins of Harappa, Buhen, and Mohenjo-daro. Paintings on the tomb walls of Thebes portray Egyptian slaves mixing, tempering, and carrying clay for the sun and dried bricks. The greatest breakthrough came with the invention of fired brick in about 3500 before Christ. From this moment on, bricks could be made without the heat of the sun and soon became popular in cooler climates. There is a wide variety of structural clay products, broadly classified as facing materials, load-bearing materials, paving materials, roofing tile, and chemically resistant materials. Examples of facing materials are face brick, terracotta brick, veneer, sculpture brick, glazed brick, and tile and decorative brick. There are types of bricks used in construction. Number 1 is the burnt clay brick, 2 sand lime brick, fire brick, fly ash brick, air brick, hollow brick. There are 5 types of materials used for bricks. The common burnt clay bricks used in general work, sand lime bricks which offer excellent strength. Number 3, engineering bricks which offer excellent load-bearing capacity. Number 4 is the concrete bricks which provide excellent aesthetic presence. Number 5 is the fly ash clay bricks may expand when in contact with moisture. In ancient times, all molding was performed by hand. However, since the invention of brick-making machines during the latter part of the 19th century, the majority of brick produced in the United States have been machine-made. Phases of manufacturing. The manufacturing process has 6 general phases. The number 1 is the mining and storage of raw materials. Number 2, preparing raw materials. Number 3, forming the brick. Number 4, drying. Number 5, firing and cooling. And number 6, dehacking and storing finished products. Let's see the figure number 1. So here are the process of clay. The mining to storage to size reduction to screening to forming and cutting until it goes to coating or glazing, drying, the firing and cooling, and the final process, the storage and shipping. These are the diagrammatic representation of manufacturing processes. Test and assurance. Take 2 bricks, 1 in each hand, and stack it each other. A good brick hears a metallic sound or ringing sound. If a brick breaks without sound, then it is not suitable for construction. Throw the brick at the height of 1.5 meter to the ground. A good quality brick won't break when it is fallen from the 1.5 meter height. Let's calculate water absorption of a brick. Water absorption. A good brick should absorb less than 20% of water when it is immersed in water for 24 hours. If the brick absorbs more than the allowable limit, if it absorbs water from cement mortar during its bonding, this eventually affects the brick bonding strength. Water absorption test on brick. To test the water absorption, follow the below procedure. Take a brick and weight it as W1. Now immerse the brick in water for 24 hours and then weight it as W2. Find out the percentage increase of brick weight by adopting below formula. Water absorption in the brick formula, percentage of water absorption in brick equals to W2 minus W1 over W2 times 100. Let's calculate the weight of a brick. Measure your brick's 3 dimensions using a ruler. For example, suppose that the brick size is 8 by 3 by 2 inches. Multiply the length, width, and height of the brick to calculate its volume. In the example, the volume of the brick is 8 by 3 by 2, 48 cubic inches. Multiply the volume in cubic inches by 0.00016 to convert it to the cubic meters. In the example, the brick volume is 48 times 0.00016 equals to 0.000768 cubic meters. Determine the density of your brick. In the example, the density of common red bricks is 1,922 kilograms per cubic meter. Multiply the volume by the density to calculate the brick weight. In the example, the weight is 0.000768 cubic meters times 1,922 kilograms cubic meter is equals to 1.476 kilograms. Multiply the weight in kilograms by 2.204 to convert it to pounds. In the example, the brick weight is 2.204 times 1.476 equals to 3.253 pounds. So that's it. Thank you for listening. Once again, I am Harif Badar Baundi, your reporter for today.